So today we are looking at graphing linear equations, and how we're going to do this is by creating what we call a table of values. Okay, so if you take a look at the first example here, they've given us an equation, y equals x plus 4, right? And we are going to pick some numbers, plug them in for x, see what comes out for y, and then we're going to be able to graph this equation on this grid. So it's very similar to what you did yesterday, but yesterday I gave you the domain or the range, and then you plugged it in and saw what came out. Today, you get to pick. So here's how I would recommend you sort of go about this. You always want at least 5 points when you're graphing a line, okay? You should have some negatives, some positives, and you're always going to plug in 0 because it's easy. So if you're looking at something like this, honestly, I'd probably pick my domain as follows. I'd probably just do -2, -1, 0, 1, and 2. You can pick any number you want. But the problem is, if you pick 100, you really want to graph 100 on this grid? No, it's going to be way off your grid. I mean, you can, but it's going to be way off your grid. If you're counting each square as 1 and you're plugging in 100, you're way off the grid already. Okay? Now, before we do this, I just also want to show you... Oh, there's none on here that are like this. Let's just pretend for a minute that I had an equation that looked like this. Y equals 1/2 x plus 3, let's say. If I get to pick whatever I want to plug in for x, what kind of numbers would you pick? If you're working smarter, not harder. Olivia? Yes, I would be picking even numbers. Because if I do 1/2 times an even number, doesn't it come out nice? Right? Like if I plug in 6, 1/2 times 6 is just 3. Why would you plug in 5, for example? That would be really annoying. You can do it, but why would you make it more difficult than it has to be? So if you are plugging in even numbers, in this case are multiples of 2, you're going to have a much easier time. What do you think you would plug in if I gave you something like this? What if it was 1/3 times x? Olivia, what would you do now? Multiples of 3. Because if I take a multiple of 3 and I plug it in and I times it by 1/3, that's still going to come out as a nice, easy number to deal with. And I don't have to deal with fractions if I don't want to. You always can, but my goodness, if you have the option of dealing with a fraction or not, wouldn't you avoid it? I would. Right? So just keep that in mind. Kind of look at your equation and ask yourself, okay, well, what makes sense here? For this, it really doesn't matter because I'm just going to add 4. So it's not easier or harder for me to add 4 to an even number or an odd number. It doesn't really matter. And you do want to have some negatives, some positives. So I might as well choose the smallest ones I can, right? So there's a couple small negatives, 0, and a couple small positives. So now, just like we did yesterday, we're going to take these numbers and plug them in and see what comes out. So, guys, when you plug in -2 for x, what comes out? +2. Everybody agree? Plug in -1, what comes out? 3. Plug in 0, you get 4. 1, you get 5. And 2, you get perfect. Does everybody agree? Everybody sees where those numbers are coming from? And now I have 5 ordered pairs that I can go ahead and graph. I'm telling you right now that all of these should come out to be a straight line. So if I plot all 5 of these points, right, as an ordered pair, -2, +2, right? If I go down the line and I plot them all, -1, 3, 0, 4, 1, 5, and 2, 6. If your dots don't fall all in a straight line there, something's not right for these equations. Of course, there are equations that aren't straight lines. Do you want to know one, just for fun? Okay, I'll tell you. If you have x squared, Does anybody know what it looks like if you graph x squared, y equals x squared? Anybody happen to know what that graph looks like? You're right, that's the same what it is equal to, but if I actually plugged in numbers for x and saw what I got out. Yeah.
Wouldn't you just double it?
You're not going to double it. You would times it by itself. So if I were to plug in, well, let's do it. Why not? Let's make a table of values for this one. Let's do the same thing. Let's plug in some negatives and some positives. So if when you plug in -2 here, what you're really doing, right, this becomes now y equals -2 squared. So that means -2 times -2. What's that?
What?
Positive 4. If I plug in -1, -1 times -1 gets me positive 1. What about when you plug in 0? What's 0 times 0? 0. Plug in 1. 1 times 1 is?
1.
And 2 times 2 is?
4.
4. So now watch what happens if I plot these points. These ones do not end up in a straight line. Watch this. So -2, 4. Well, let me give myself. Okay, if I do -2, 4, that's here. -1, 1. Oh, I didn't. I did -1, 4. Oh, Miss Savia, you're so silly. There's -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. Check this out. When you have an x squared, it forms a U shape that we call a parabola. How cool is that? So anytime you graph something that has an x squared, anytime, that's how they come out. U shapes. Pretty neat. Okay, so all the ones that we're going to be doing though should be straight lines. I just wanted you to know that there are graphs that are not straight lines. They exist. There's an example. So cool. All right. So let's try number 2. This should be a straight line. Are you going to pick anything special? If I'm doing 3 times the number minus 1, do I need to be careful about the numbers that I plug in? No. So I'm probably just going to stick with my -2, -1, 0, 1, 2. So take a minute and see if you can figure out the y values for these. If you need to, there's some space over on the right hand side if you need some space to do some work. Once you have your y values filled in, if you're confident, go ahead and plot them on your grid. And let's see if you end up with a straight line or not. How'd we do? We got something? When you plug in -2, what comes out? -7 in the end, right? Because you're going to do 3 times -2, which is -6. -6 minus 1, that's how we land on a -7. -1, you'd get -3 right there, and then -3 minus 1 is? -4. We should have, right? -3 minus 1, -4. 0. -1 comes out, yep. Now we get to plug in positive 1. So that's just going to be 3 minus 1 is 2. And then 6 minus 1 is 5. Perfect. So double check that those are the range values that you got out. And now we just have to plot these. So hopefully we're okay at plotting. -2, -7. -1, -4. 0, -1. Remember that's, you don't go left to right, you just drop down 1. 1, 2. And 2, 5. Yes, everything fell in a nice straight line. So I'm pretty happy about that. If you feel like connecting the dots, you can. Let's jump to number 4 if we could. Because number 4 is a little bit different. Huh. Isn't this weird? Should we be plugging in any special numbers? No, I'm not multiplying by half or a third or anything like that, so I can just pick whatever I want. So let's stick with our same ones. Okay. So now we're going to plug these values in and see what happens. If I plug in -2, well, this is weird because there is no y at all. Actually, I wouldn't even make a table of values for this, to be honest with you. Because I don't have a y, so why would I even bother with a table? I wouldn't. Okay, so if there's only one variable, here's what I would do if I were you. Look at my equation. Can I get the x all by itself? How? Add the 2 to the other side, okay? So if there's only one variable, get that variable alone. So we'll add 2 to both sides. So that gets me just, I'm going to write it over here, x equals 2. There's no y value at all. This is still going to be a straight line. No, go for it. What do you think you do? Yes. Oh, well, which is it? Yes. Here's, where is x equal to 2? Isn't this the x-axis, right? Right, do you see that? And isn't x 2, right? X is 1. Here's where x is 2, right there. But watch this. Let's pick this random point right here. Isn't its x value also 2? Right? Remember, I don't have a y, so I don't even care about the y's. Doesn't this point right here also have an x value of 2? Doesn't this one have an x value of 2? What about this one down here? Isn't every single point on this line, isn't the x value 2 everywhere? It says nothing about y's. I don't care about the y's. So what happens when you have a variable, just a single variable, you end up getting just a perfectly vertical line or horizontal. How do you think I end up with a horizontal line? What would my equation have to look like? Yeah.
No x, only y.
Correct. If I only had y's and no x's. I do have a little way to help you kind of remember this. It's 2 funny little words. Are you ready for the funny little words? Maybe you've heard them before, I don't know. The first word is hoy, H-O-Y, and then the second word is vux, V-U-X. Hoy vux. These two funny little words. Let me explain to you how they work. The first letter tells you if it's horizontal, or if it's V, it's vertical. The middle letter deals with slope, which we haven't talked about yet, but we will in a little bit. So you can actually just ignore the middle letter for a minute. But then the last letter tells you its equation. This will be a y equals, this will be an x equals. So in our case, we had an x equals. So that means, it's going to be a vertical line. Do you see how that works? Once you figure out if it's x equals or y equals, because kids always mix them up. They're like, okay, it's x equals. I know it's vertical or horizontal. Well, which is it? If you remember Hoy Vux, okay, so you're either going to be dealing with Vux or you'll be dealing with Hoy. Okay, so if we look at number 5 together real quick. This one, same thing's going on. It's just that this time I don't have an x. I only have a y. So what should I do first with this? Yep. Right. I want to get the y all by itself. So let's minus 5 to the other side. So now my equation looks like this. Y equals -5. All right, great. Now, if you remember, I only have one variable. So that means I'm going to be dealing with Hoy Vux. And then I say to myself, okay, it's y equals. So I'm not dealing with this guy. I'm dealing with this one because I'm dealing with the y. So what does my graph look like? It's horizontal. So you just draw a horizontal line at -5. So drop down to -5 and draw a horizontal line right there. Does that kind of make sense how those work? Yeah, so for those, I really wouldn't bother with the table of values because it's not going to help you any because you're missing one of the variables. So, what are you supposed to do with them? I'm sorry? Yeah, you're better off just stick with Hoy Vux to help guide you through. We'll do one more together, and then I'll give you your homework. Okay, good idea. How about 6? This one does have 2 variables, so I would use a table of values. Do I have to be careful with what I plug in? No, I'm really only careful if I'm multiplying by a fraction. Otherwise, I can kind of do what I want. So let's just stick with our -2, -1, 0, 1, 2. Now be careful here. The y is there, so I'm going to do 2 times -2, that's -4. And then won't I have to add the -4 over to the other side to get the y all by itself? So if you want to do some scrap work over here, let me see if I can zoom out and do it all at once. So I've got 2 times -2 plus y equals 4. So that's -4 plus y equals 4. So let's go ahead and add that 4 over. So I get 8 when I plug in -2. Did you? Okay. And then we can do the same thing for -1. 2 times -1 plus y equals 4. What'd you guys get? 6, that's what I got. 0, you might be able to do that one in your head. It's just 4, right? You might be able to do 1 in your head too. If you plug in a 1, what's going to come out for y? 2. Because you'd have 2 times 1 is 2, and then subtract that 2 from 4, you get a 2. And plug in 2, you might be able to get that one in your head too. That's got to be 0. Because 2 times 2 is 4. 4 plus what is 4? It's got to be a 0. Awesome. So now we have 5 points. Let's go ahead and plug them in. They all fell in a nice point, or a nice line. Okay, good job.